So this video is going to be the last section for Unit 4. We are going to learn how to solve simple quadratic equations. So our goal is that you can solve simple radical equations or quadratic equations, and you can put these answers into simplest radical form, which is using everything we talked about so far in Unit 4. So remember, when you're solving equations, you use inverse operations. So opposite of adding is subtracting. Opposite of multiplying is dividing. And the one we haven't did when we did this in Unit 1 is what's the opposite of squaring? Well, the opposite of squaring is the square root. Or if you want to undo a square root, you square. So these two undo each other. So that's going to be an important fact. We're going to use this when we're doing these equations. Also remember, when you first did the first section of Unit 4, when we take the square root of 9, a lot of you guys would automatically say, well, square root of 9 is 3. But also remember, 3 squared is 9, but also negative 3 is also 9. So we have two answers. And you can write it as 3, negative 3, or plus or minus 3. So most of our answers with these equations are going to have two answers, and we're going to need that plus or minus. We are going to apply that rule. Also, can we take the square root of all numbers? And the answer is no. If the number is positive, the square root of 9. So the square root of 9 we said was plus or minus 3. What about the square root of negative 9? Is that possible? If you type in your calculator will give you an error or a domain error, something like that, and saying you can't do it. And the reason why is that we need two numbers that are exactly the same, that multiply together to be negative 9, because that's your answer, because 3 times 3 is 9, and negative 3 times negative 3 is 9. That's why these are answered. Well, the only way to get negative 9 is 3 and negative 3. Well, 3 times negative 3 are not the same. So since our two numbers are not the same, this is not possible. So when we get this situation where we're solving equations, this is going to be our no solution. One last fact before we get started looking at a bunch of examples is when we solve radical equations, we need to isolate. So remember, isolate is by itself, x squared. So we need to get x squared by itself. All right, so we're going to solve, and we're going to, again, the key is put your answers in simplest radical form, which means no decimals. We're going to use what we learned this unit when we're solving these equations. So on A, so we have our two sides. Again, we want to isolate x squared. So we're going to add 36 over first. So get x squared equals 36. Now we need to undo the square, and we said the inverse of a square is square root. They undo each other. If you had 3 squared and you undid that, that would just be 3. So x, and then what we do to one side, we have to do to the other. So we have x, because they cancel each other out, and the square root of 36, well, the square root of 36 is a perfect square, so that is 6, but remember there's two answers, so this is plus or minus 6. You need both answers, plus or minus 6, and again you can write it as 6 or negative 6. So on B, so first I'm going to move when I'm adding and subtracting, so I'm going to move 98. I get 2x squared equals 98. X squared is still not by itself. I have 2 and they're multiplying in between, so I'm going to divide. So I get x squared equals 49. Square root of 49, because I'm undoing the square, is 7, and then I need plus or minus 7. And again, you can go ahead and check your answers by plugging these in. 7 squared is 49. 49 times 2 is 98. 98 minus 98 is 0. So I know that is the correct answer. So on C, now we're going to get more where you're going to have to simplify. On C, so I'm going to add 25. Cancel out, so I get 9x squared equals square root of 25. X squared is still not by itself on the left side, so I'm going to divide by 9. So get x squared. Now, if this simplified into a nice integer, a nice number, I would simplify that down, but since it does not simplify, I'm just going to leave it as a fraction as 25 over 9. And I'm going to square root. So I have x equals plus or minus this expression. So then we have to remember how we simplify this. Well, to simplify this, we split the root. Now, some of you might be tempted right away, oh, we need to rationalize the denominator and move it up. But remember, if you know your perfect squares, you should quickly simplify this, because the square root of 25 is 5. The square root of 9 is 3. So my answer is 5/3. And just leave it as 5/3. You don't need to make it into a mixed number. It's fine just to leave it there. Again, don't forget your plus or minus. So in D, I'm going to minus 6. 2x squared equals 0. Divide by 2. 0 divided by 2 is 0. Square root. X equals, square root of 0 is 0. And on 0, we don't need plus or minus because 0 is neither positive or negative. It's just 0. So we only have one answer with this one versus the 2 we were getting before. E, so I have positive 4, so I'm going to minus 4. So I have x squared equals negative 4. Square root. X squared. A lot of you will, we're just going to get x. And a lot of you guys are going to be tempted, oh, the square root of 4 is 2, so it's plus or minus 2. But it is negative. You cannot take a square of a negative number. There are no two numbers multiplied together that give you negative 4. So my answer is no solution. If you get a square root of a negative number, there is not an answer. All right, so on F, minus 5, I get 2. X squared equals 90. Divide by 2. X squared equals 45. Square root to undo my square. X equals square root of 45. 45 is not a perfect square. Again, that's plus or minus. So now from this point, since I'm doing simplest radical form, I need to break down the square root of 45. So that is 9 and 5, 3 and 3. So this equals plus or minus. I have a pair of 3's, so that's 3, and then square root of 5. So my final answer is x equals plus or minus 3 square root of 5. So on G, minus 8. Get x squared equals 112. So I'm going to square root. Also, again, 112 is not a perfect square, so I can break down 112. I know that's 2 and 56. 56 is 7 and 8. 2 and 4. 2 and 2. Alright, so x equals plus or minus, can't forget that plus or minus. I have two pairs of 2, so that's 2 times 2, which is 4. And then, I forgot to circle my 7, square root of 7. Don't forget to circle your primes, otherwise you're going to miss them like I almost did. Alright, so on H, 3 square x squared, so I'm going to divide by 3. Again, this fraction is not nice, so I'm just going to leave it as a fraction. That's an improper fraction. 7/3 square root. So I get x equals plus or minus square root of 7/3. Now I can look. Oh, it's 7 and 3, or I can split this as square root of 7 and square root of 3. We are allowed to do that. These are equivalent expressions. Square 7 and 3 are not perfect squares, so now I need to rationalize my denominator. So I'm going to multiply by square root of 3, square root of 3. Get plus or minus 7 times square root of 3 is square root of 21. Root 3 times root 3 is 3. Square root of 21 does not break down anymore. There's nothing on the outside to simplify. So that is my final answer in simplest radical form. One last one. going to be very similar to the one we just did. So I'm going to minus 6. So 8x squared equals 3. Divide by 8. So I get x squared equals 3/8. Again, this fraction does not simplify or divide out nicely. So I'm going to square root. So x equals square root of 3/8. So I can write that as square root of 3 over square root of 8. Split it up. Have a root in the bottom. Neither one of these are perfect squares. So I'm going to go square root of 8 to top and bottom. Get the square root of 24 over 8. Some of you guys may be tempted to stop there like we did in the previous one, but again, you always have to check. Square root of 24, well, we know that's 3 and 8. 3 is prime. 8 breaks down into 4 and 2. 2 and 2. Alright, well, we have a pair of 2's that go outside, and a 2 and 3, so that's square root of 6 over 8. Okay, so we know square root of 6 is done, but they're going to check the outside. They divide out to 1 and 4. So x equals, don't forget the plus or minus after all that work. Get it wrong after doing all the hard stuff. So we get square root of 6, because 1 times square root of 6 is just square root of 6 over 4. That's your final answer. So that concludes this video. I'm just going to review. Remember, you have to isolate x squared. Don't forget the plus or minus. I cannot tell you how many students get these problems wrong over something so simple about forgetting the plus or minus. And this plus or minus only goes with the equations. You don't need to worry about plus or minus when we're simplifying the other ones. I only want them with equations to show you that there's 2 answers to each of these equations. Remember your rules for simplest radical form. This video is kind of a good review of the entire chapter. We didn't do any of the conjugates, which is okay. We're not going to do anything that difficult. And then you can take a square root of a negative number. So if you have that situation, like the square root of 3 or square root of 4, like we did in the example, you write no solution. Just a reminder to do your reflection so you get credit for watching this video.